As we go through solving logarithmic equations and exponential equations, it is again we're going to be working back and forth out of a couple of properties. We're going to work back and forth out of undoing logs like this, or undoing logs like that. Both of those two properties come up pretty regularly, as well as the condense property, more so than the expand. So you'll see those things pop back and forth as well. You may or may not, actually may, hint, have to use this. It is a strong possibility that that will show up as well, because sometimes you have to factor something, and sometimes you have to factor something that might not be very easy to factor. See what I did there? That's pretty good. Synergistic mathematics. So, one of the things we have to do, one of the properties that we can do is that if you get, when you have common bases on both sides of an equation, you can log base it and everything drops down. Remember, when you're solving and working with equations, if you keep things balanced, everything stays the same, everything works. Numbers are jealous, so they want to make sure that you work with both sides. So if I'm looking at an 8 and a 4, what would be a different way to write that out in terms of a common base? The base what? 2. Okay. 4 and 8 are both, when you see these things, you have to start thinking of powers. 4 is 2 squared. 8 is 2 cubed. So I can rewrite this as 2 times 2 squared to the times 3x. Okay. Now, once you get the same base on both sides, you have base to the exponent, what happens here is that if I take the log base 2 of both sides, remember the property, log base b of b to the x equals x, because those bases undo each other. It's basically what you're doing here. Once you get a common base on both sides of an equation, you technically log base both sides, and the exponents come down. And you wind up with 6x equals 3x plus 1. You don't. Thank you. You're not doing your calculator here yet. Because it undoes itself. Because remember we did this yesterday. What was the log base 7 of 7x? Right. So if you do this to two sides of an equation, you're keeping it balanced. So the exponents come down. Okay. You don't have to worry about the calculator yet. Well, we'll get to the one where we have to press buttons on the calculator, but a lot of times this is the setup to undo stuff to get you to a calculator. Yes, sir. Oh, I'm sorry. Sorry, I didn't know what you were at. Go ahead.
In a situation like that, when it ends up being x equals x, when you just create like all of these.
Yeah, and we'll get to that. All those types of equation stuff all hold true still. So you get to this point here, and you get subtract out. You get 3x is 3. X is 1. All right.
Whenever I make a
Pretty much all right. Mid. Okay. So you don't even do 2 of them. Let's just do one more. I have 9 to the 2x equals 3 to the x minus 6. Very good. So you want to rewrite to a common base. The common base between a 3 and a 9 is going to be 3. Good. So I rewrite it as 3 squared times 2x. So the exponent stays 2 times 2x equals 3 to the x minus 6. Are those bases the same on both sides of the equation? Is there anything else after that? No. What I mean is there's no like an extra tack on plus 2 here. Okay? And, well, oops. So this is that same idea. All you have to do is you would log base 3 both sides, exponents drop. And you get 4x equals x minus 6. Okay, that's how you're undoing these things. 3x equals negative 6. You get negative 2. You're not buying it.
No, I am.
All right, you just kind of have the. That's right. Not enough sugar yet.
I know the answer, so I get it.
Other side. Gentlemen, enough. This was, sorry, that didn't write up very well. So this was kind of the first example that I showed you guys when we started talking about these things called logarithms. Remember I said, what was it, 2 squared was 4, 2 to the third was 8, but 2 to what power is 6? Well, in order to be able to figure that out, you have to, in this case, you have to know how to use the calculator. This is the style problem you have to jump basically right to the calculator. Now, when you have one like this, in order to get the exponent to come out, since you don't have common bases, you have to log base, in this case, what are we going to use for log base? 2. You're going to take log base 2 of both sides. So if I take the log base 2 of 2 to the x, I have to do that to the other side. What's log base 2 of 2 to the x? X. So that means x is going to equal whatever the log base 2 of 7 is. Well, I think I showed you yesterday or the day before how to get a log base in your calculator, and it was an alpha window 5. Alpha window 5. I think that's going to be my new band name. The alpha window 5s and the mighty asymptotes. It's pretty good. And I like to round to 2 decimal places always, so it'd be 2.8. Wrong section. Okay. Same idea here, guys. If you have just 2 to the x on one side, you log base it. But if there's other things around it, you have to work backwards. Remember, you're working backwards from PEMDAS, so you're using your SAD. Okay. Do another one. For example, 10 to the 2x minus 3 plus 4 is 21. Again, treat it like you would normally. Working a regular equation, working backwards. What's the first thing you're going to move? 4. So you would subtract 4 from both sides. What is that, 17? Now, I have nothing else to do but log something. What log base do I use? 10. Now this is the case I can just can hit just log. I don't have to use the alpha window 5 to do base 10. I can hit log. So log button is that one next to the 7. It says log, kind of helpful. So if you log both sides, you're going to get 2x minus 3 equals the log of 17. Now, log of 17 is just going to be some crummy decimal. Do you agree? So when you do this, let me move this over so you can see it. All we have to do is hit log of 17, hit enter, Now, you guys probably know that 2x minus 3 equaling junk. Well, how do you move the negative 3? So you add 3. And then how do you undo multiplying by 2? You divide by 2. And you're basically just using your calculator right there. 216. Yes, ma'am. Absolutely, absolutely. You can't do log equations without calculators.
So what all is going to be on the
Non-calculator would be like expanding, condensing.
Okay.
Maybe an inverse. You know, flip-flop x and y and just resolve. What are the ordered pairs that you would use for an exponential or a logarithm? You know, they're just real quick. Yeah. Yeah. Okay. All right. Logs. When you're solving log equations, you have to do something different. When we solve log equations, we have to do something different here. So if I have a log base 3 of the quantity 5x minus 1 equaling the log base 3 of x plus 7, first thing you want to notice is that they have the same base. That's good, because if they don't, nothing's going to happen. Okay? Since you have the same base on both sides, you can treat it, remember how we did that with the exponential ones? If you have the same base on both sides, the exponents dropped. Here it's the same basic idea. Instead of getting the exponents to drop, what we're doing is we're going to create what's called an exponentiation. We're exponentiating because the property b to the log base b of x is x. So by raising the logs as exponents with this base, it undoes it, which drops out and gives you 5x minus 1 is x plus 7. Right. Yes. By exponentiating, you undo a log. To undo an exponent, you log it. To undo a log, you exponentiate it. Exponentiate it. Okay.
That's pretty neat.
So add 1, subtract 1, and you get 4x is 8. What's x? 2. All right. Real quick, can you take logs of negatives? Try that. So always double check your answers, especially with some of these things, and especially with log stuff. Double check for extraneous solutions. Oh, speaking of ambulance, I do not have the ambulance here, but I have an idea.
Wait.
It might just be.
You could give me a little answer.
What fun would that be?
I don't know. It was a little bit.
Come on now. It's like the middle of February. Haven't you figured out that I'm kind of not that cut and dry? I'm more wishy-washy-ish. All right, so you have log base 2 of something equals log base 2 of something else. If I 2 both sides, the logs go away, right? So we know that since these bases are already the same, as soon as I exponentiate them, the logs drop. Okay. You drop the log. See what I did there? It's funny because it's like a poop joke. I'm like 9, which my son just turned into. So. Happy birthday to Connor today. Is it your birthday? Oh, that's right, it's your birthday. Happy birthday, Mackie! Yay! Mackie, what times 1 is -2? You have to get -1. Which ones? Way to go, Mackie. So, what are your solutions?
Power of Christ compels you.
So, it's Mackie's birthday. It was Mackie's birthday. He factored in probably had logarithms. Congratulations. We do logarithms so much. So,
Why are you factoring logarithms?
why not?
Oh.
I'm just showing them what the factor is here. So, real quick, what you would do is just throw in the negative values, make sure it works. What's negative 1 squared? 1. What's negative 1 plus 2? Is the answer on the ceiling tile? What? In this case, both solutions work. They're going to be okay. Right? So you always double check. Okay. We did that one. All right. Sometimes when it is not convenient to get rid of the logs is when you have to press extra buttons on the calculator. Okay. And you'll notice real fast, the ones that you're just pressing buttons on the calculators are the absolute easiest ones to deal with. Okay. Because you have a calculator, you're right. But even the other ones, I'll let you have a calculator, but you still got to, it's not like it's tough. So, I can't just get rid of the log here because there's only one log, there's not two. So what we have to do is we have to exponentiate both sides. So what do I have to exponentiate the left side to get rid of the log? I have to 5, so it's going to be 5 to the log base 5 of junk, and which is going to be equal to then 5 squared. By exponentiating, if you exponentiate both sides, it stays balanced. Nothing changes. Okay? You're still raising, you're taking that log and you're raising it to become an exponent. That base 5 and the base 5 of the log are the same, so they cancel each other out. They're inverses, which leaves you 3x plus 1 equals 25. Sometimes you will. Oh, you mean what were you saying?
Like, why is it 5?
Because if it was 5, because you're exponentiating, because this is, remember the property, b to the log base b of x equals x.
So you raised to the log. Okay, I get it.
Okay, you're great. Remember that e to the x and log base, I'm sorry, not e to the x, b to the x and log base are the same. All right, they're inverse operations of one another. So remember we did log base b of y equals x, b to the x equals y. That's why all this works, because these are inverses. They undo one another. Yeah, these are easy. Actually, let me try show this one real quick. So, when you're looking at this one, think of it as what do you want to do first? All right, so you move the 15th, then what are you going to do? Well, you can do it, let's think of it this way. Let's try it both ways. Because isn't this, now let's try both and see what happens. Do you agree that this is the same thing as saying 15, well, when we move it over, we're going to get 2 log base 2 of x equals 16. You guys agree on that? Do you agree at that?
Yes.
What do you mean? I'm condensing because the 2's out in front. I'm gonna go both ways here. All right. And then you're saying divide by 2. And so far you're like that? Everybody okay with me so far? Now, how am I gonna undo the log of both of these? I exponentiate it with a 2. Okay. So I'm gonna get x equals 2 to the 8. What's 2 to the 8?
256.
Okay. I just started on that one. Now, what's 2 to the 16th?
Yeah, 2 to the 16.
655.
All right, take the square root of that.
256.
Does it matter which way you use? No. And that's the idea. With some of these types of problems, especially with the properties that have the exponent in front of, or I'm sorry, the number in front of the log, where we become an exponent, sometimes it's easier to treat that as just divide out, because your numbers will be smaller as opposed to having to exponentiate things out, because then you get really, really large numbers. Okay. Either way, it's going to work. I want you guys to see how that goes. I just want to show you how that works. So far, so good? Okay. Let's make it more interesting. More fun. Stagnation is boring. I don't mean to crush your soul right there. I'm sorry, but you're like, oh crap, Murphy. Thanks. All right. So in this case here, since you've got the addition on the one side and no logs on the other side, you have to condense first. Okay. So how do you condense when you have addition between two logs? Multiply. Good. So I'm going to get log okay. How do I undo this log? I exponentiate with a 10. When there's no log, when it just says log, it means it's base 10. Okay. So we exponentiate with a 10. Now, that gives me 5x times the quantity x minus 1, which is 5x squared minus 5x equals 100. Bless you. Which means we have to factor again. Subtract over. Correct. If you take out the 5, you get x squared minus x minus 20, I believe. All right, Mackie, you factored so well a minute ago. We're going to have you factor one more time because you're so good at it. What times what's negative 20? You add together to get negative 1. Negative 5 and 4. Way to go, Mackie. Again, happy birthday to Mackie, ladies and gentlemen. Wasn't somebody else's birthday here today, too? Or was that the other class? So you have two solutions. You have 5 and negative 4. So you go back to verify whether or not they both work. And we can't take a log of a negative, so we know that I know that I can't take log of negative 20, so that goes away. Not so bad. It's pretty easy. want to give you a natural log.
I just saw my worst nightmare next to that
Yesterday, I think I started this problem with you guys to show you why we had to use condensing properties to be able to solve for x. Okay? So let's finish what we had started yesterday. In this case, I've got the natural log of x plus the natural log of the quantity x plus 3 equals 1. Okay? Now, what do you think you should do on the left-hand side to start? Condense, very good. Since it's got an addition symbol between the two, what do you have to do? Multiply, good. So you get natural log of x times x plus 3 is 1. Natural log is log base what? E, very good. So this is the same thing as saying log base E. So how do I undo log base E? We exponentiate it with an okay. What's e to the 1? E. So you get x squared plus 3x equals e. E is just some constant. It's just some number. I don't know what it is, but I'm just going to move it over. Yeah. What multiplies to negative e but adds the other to get 3? Well, what's your a, b, and c here? 1, 3, and negative e. So let's sing it. Everybody sing it for Mackie. Ready? X equals negative 3 plus or minus square root b squared minus 4ac all over 2. You guys are going to miss singing the song next year. I don't think Debbie sings it.
It's gonna be great.
Awesome. So in your calculator, there's a button. It says E. The one thing you got to be careful of is as soon as you hit the button that says E on your calculator, it tries to go to an exponent. In this case, what's the exponent of E? Oh, is there? Look at that. Oh, it is right. That's right. Yeah, you can do that one. Yep, that works. It's the same thing. That E versus if you use the E to the X down here, you just have to make sure that that goes to a 1. Okay? Either one of them is fine. Okay. I had completely forgotten that there was the E button above the division symbol, so I forgot it was there. Thank you. Thanks. So in my calculator, I'm going to type in this beautiful looking thing in the underneath the in the discriminant. I don't know what that was called first. So if I type the discriminant in, I get 9 minus 4 times 1 times negative E, and I get some crummy decimal. You okay with that? There's my discriminant. My discriminant is positive, therefore I have 2 real zeros. So I take the square root of said number, second square root of my answer. Oops. I hit the wrong button. Second square root of my answer. And hit enter. Oh, you do that too. This one's quicker. So that's the square root of it. Okay? So it's going to be negative 3 plus or minus 4.46 over 2. So here's what we do. We do this. We add 3 to it. Oh, sorry, add negative 3 to it. Divide it by 2. And I get And then I do the same thing. I'll go. This is where you have to. It's sometimes easier to go back up, and then I just move it in front. I know. So insert. Divide that by 2. And then you have to go back and think, all right, will that negative 373 give me a negative value for up here? Yeah. That negative value is not going to work because I can't take logs of negatives. So technically I only have one solution there. So you still got to verify if you're going to wind up with extraneous with E. Why did you just become David real quick?
It's like, listen, 10.5. Okay, guys, time to go to the management block.
You guys are crazy. Here, do these. They are so fast to work with. I could have just said do these and skip like 2 of them, but so which one do you guys? Ooh, I'm sorry. Hold on. Let's wait. I got. Oh, that's why I skipped a couple of them in there because some of them had the negative stuff. Yeah, this was fine. Yeah, otherwise it's too much more working and stuff. Yeah.
You are blocked. Okay, I won't do the homework.
Yeah, we'll do that one in class tomorrow. I'm sorry. I wrote down that you had to skip because there are some negative exponents we have to deal with.